This is section 5.4, half angle formulas. The formulas for the half angles are based on the formula for the double angle. And so I'm going to rewrite this really quickly to show you how these things are related. And what I'm going to do is I'm going to say the cosine of 2x, because it doesn't matter what we use to represent the angle, is equal to 1 minus 2 sine squared x. Okay? And so when I rewrite like this, here's what I'm going to do. I'm just going to switch the sides. Because I'm going to be working predominantly with the left side. And what I need to understand is I'm solving for an angle that I don't know. Okay, and so it doesn't matter whether it's x or a over 2 or theta over 2. It's an angle that I don't know. So what I'm going to do is I am going to solve for sine of x, and you're going to see what happens. So I have negative 2 sine squared x is equal to the cosine of 2x minus 1. Okay? And so what I'm going to do is I'm going to divide by negative 2 on both sides. So I've got sine squared x is equal to, now I'm going to do a little bit of rearranging here. I've got minus cosine 2x plus 1 over 2. So I distributed this negative to the 1 and the negative to the cosine. And when I switch it around, sine squared of x is equal to 1 minus cosine of 2x over 2. And I'm going to take the square root of both sides. Sine x is equal to square root of 1 minus cosine of 2x over 2. Of note here, it doesn't matter what x is. So I'm going to let x equal a over 2. So therefore, when I plug it in here, and I plug it in here, I get the sine of a over 2 is equal to the square root of 1 minus cosine and 2 times a over 2 equals a. 1 minus the cosine of a over 2. Okay? Stepping over this way. We would follow a similar process to solve for this. If you'd like to do that, you certainly may. But what I'm going to give you is that the cosine of a over 2 is the square root of 1 plus cosine of a over 2. Both of these formulas are going to be positive or negative depending on the quadrant. Okay, so that's kind of how this works. What we need to do with this example then is we're saying here's the cosine of a. And a is in this quadrant. A is between 270 and 60. So we want to find these three things. Well, what we need to do first is we need to say if 270 is less than a, which is less than 360, we want to know what a over 2 is. So I'm just going to divide by 2 on all accounts. So 135 is less than a over 2, which is less than 180. This puts a over 2 is in the quadrant number 2. Okay? So this is in quadrant 2, which means, follows from that if the coordinates go sine theta, comma cosine theta, cosine theta, comma sine theta, then in the second quadrant, cosine is going to be negative, sine is going to be positive, and tangent is going to be negative. Okay? Let's see how this works out. If the cosine of a is 3 over 5, then I want to find the sine of a over 2, which is equal to, now I'm going to use my formulas, 1 minus cosine of a over 2 square root of 1 minus 3 over 5 over 2. So 1 minus 3/5 would be 2/5 over 2. You can think of this as 2/5 over 2 over 1, which is equal to 2/5 times 1 over 2. The 2's cancel. So we end up with this being 1 over 5 And we're remembering, of course, that we're taking the square root of all these things. So this is equal to 1 over square root 5. Now, because it's in the second quadrant, sign is positive, so this is my sign. Okay? So this is 1 over square root 5. To find the cosine of a over 2, take the big square root, (1 plus cosine of a over 2). So we will simplify. We have 1 plus 3/5 over 2, still keeping the square root. So we have 5 over 5 plus 3 over 5, which would be 8 over 5 over 2, which is equal to, now 8/5 divided by 2 would be 4/5. Still square rooting, so we have 2 over square root 5. And remember, cosine is negative in this quadrant, so this is going to be a negative 2/5. Negative 2 square root 5, that is. And the tangent is going to be sine a over 2 over the cosine of a over 2, which is 1 over square root 5 over negative 2 over square root 5. So this is going to be negative 1/2. Okay? So that's how this works. Alright? So this is what we can do with these things. Okay? And so let's move on to tangent of a over 2. The tangent of a over 2 really gives us just a simple formula. It's actually a lot easier than some of the other formulas. And that's all it is. That's the tangent of a over 2. And so when it says tangent of 15, something we can do is we can say that this really equals tangent of 30 over 2. Okay? And so that makes a equal to 30. Well, when I use this formula here, that's going to mean I have 1 minus cosine of 30 over sine of 30. This is good news for us because we know these formulas. We know what this means. So this is 1 minus square root of 3 over 2 over 1/2 because I substituted. So what I end up with is 2 over 2 minus square root of 3 over 2 over 1/2. I'm going to simplify, so I have 2 over 2 minus square root of 3 over 2. And I'm going to be multiplying this by 2 over 1 because I'm reciprocating the denominator. So this 2 cancels in all of these because I would distribute. Okay, so I end up with 2 minus square root 3. Okay, that's the simple answer right there. I did something a lot easier for myself. Example 4. We're going to graph this. And the thing about graphing something like this is really y equals 4 cosine squared of x over 2. Let's look at what this means. I see obviously that this is a half angle formula. So I'm going to have 4 times, okay, cosine of a half angle. Let's look at what the cosine of a half angle is. Really, I'm dealing with a cosine, but it's underneath the square root. Okay, so square root of 1 plus cosine of a over 2. But I'm squaring this. And so when I square this, I really end up with 4 times no square root. 4 times 1 plus cosine of a over 2. Watch how this plays out. So this is going to be distributed to each element. So 4 plus 4 cosine of a over 2. I factor out a 4, so I've got 4 times 1 plus cosine of a over 2, and I divide, so this becomes 2 up here. I can redistribute that. So I end up with 2 plus 2 cosine of a. Okay? But when I end up with 2 plus 2 cosine of A, I know how to graph this. Amplitude, period. Phase shift, vertical translation. Vertical translation is the easy one. Phase shift I don't have. Okay, so I'm not going anywhere with it. Amplitude is 2, period is 2 pi. And so what I'm going to do is, I'm going to divide my interval. I've got 4 pi here, because I know I'm going all the way to 4 pi. And I know that my amplitude is going to be 2. And so when I start this, okay, my period is going to be 2 pi, so I still need to divide these in half. Okay, so one period is going to go like this. Cosine graph starts up high. It's going to go okay, and it would continue to go in this way. Okay, I missed my point here. This should be over a little bit. And then, so that's accounting for this, accounting for this, accounting for this. Now I need to just move it up 2. So I'm going to move all my points up 2. So we'll end up looking something like this. All of these move up 2. This moves up 2. This moves up 2. Up 2. Up 2. Up 2. Up 2. 2. 2. My final graph looks like this. Okay, and that's how we graph that. Notice it wasn't as hard as it looked because I simplified using my formulas. Last proof. We're going to prove that this is true. Obviously this side looks complicated, but this side has the half angle in it. So what we're going to do is we're going to say that this is sine of x over 2 squared, and we're going to expand this. Okay? We're going to expand this side. How are we going to do this? Now, we have, this is square root of 1 minus cosine of x. I wrote a. So this is 1 minus cosine of x over 2. We're squaring that. So this is going to be 1 minus cosine of x over 2. Here's the problem. The problem is, when I compare this to this, I've got this tangent in the bottom. Well, let's see if we can't force a tangent to be in the bottom. So I'm going to multiply by tangent over tangent. And when I distribute this, I get tangent x minus tangent x times cosine x over 2 tangent of x, which really equals tangent of x minus sine x over cosine x times cosine x over 2 tangent x. These cancel out, so I'm left with tangent x minus sine x over 2 tangent x. I forced the denominator to look like the denominator on the other side, and I ended up proving my identity. Okay guys, so that's half angle formulas. Thanks for watching. We'll see you next time.